Welcome everyone. Today in our third lecture, we'll be diving into data visualization. We'll start by exploring pandas, move on to various visualization libraries, and then apply these concepts to visualize the Monty dilemma we discussed in our last session. First, let's begin with pandas. Pandas is a fundamental Python library for data analysis. Whether you are a beginner or looking to strengthen your skills, this session will help you understand pandas in an easy and practical way. Let's dive in! Why should we use pandas? Simply put, pandas makes working with data much easier. It provides efficient ways to manipulate and analyze data, making complex tasks simple. It also integrates well with other libraries, which makes it a must-know tool for data analysis. Before we can use pandas, we need to install it. Simply run pip install pandas in your terminal. Once installed, we import it using import pandas as PD. We use PD as a shorthand to keep our code clean and readable. Pandas has two main data structures, series and data frame. A series is like a single column of data, while a data frame is a full table with multiple columns. Let's look at some examples to better understand them. We can easily create a data frame using a Python dictionary. Each key represents a column, and the values are stored as rows. This is one of the most common ways to create data frames in pandas. One of the main strengths of pandas is how easily it can read data from files. You can read CSV, Excel, and JSON files in just one line of code. This is essential for handling real-world datasets. After loading data, it's important to explore and understand it. The invoke function gives us an overview of the dataset, while describe provides statistical insight. The head function allows us to check the first few rows quickly. Real-world data is often messy. Pandas provides easy ways to clean it, such as handling missing values and removing duplicates. These steps ensure data quality before further analysis. Pandas allows powerful data manipulation techniques. You can sort, filter, and group data effortlessly. This is useful for analyzing large datasets efficiently, especially when filtering data. It's easy to run into errors due to the frequent use of parentheses and brackets. Pay attention to using parentheses and brackets correctly. Also, if you open one, don't forget to close it. Pandas has built-in visualization tools that integrate with Matplotlib. You can create bar charts, line graphs, and more with just one line of code. This makes it easier to analyze and present data. Congratulations! You now have a solid foundation in Pandas. To improve further, practice with real datasets and explore advanced functions. Keep learning and experimenting. Now let's get started with Chapter 2. Visualizing data is a crucial part of data analysis, allowing us to identify patterns, trends, and insights that may not be immediately apparent in raw numbers. Instead of struggling to interpret endless rows of data, the right visualization tools can help transform complex information into clear, meaningful visuals. In Python, two of the most powerful libraries for data visualization are Matplotlib and Seaborn. Mastering these tools will give you a significant advantage, enabling you to communicate data effectively and uncover deeper insights. Think of it as adding a powerful weapon to your analytical arsenal, one that will help you make smarter, data-driven decisions. Let's dive in and explore how to use them. Before we start, we need to install the libraries. Think of this as downloading a game before you can start playing. You wouldn't just stare at the store page forever, right? Just run pip install matplotlib seaborn to install them. After that, we can import them into our Python code using import matplotlib, pyplot as plot, and import seaborn as sense. We import it as plotty for convenience, so we don't have to type matplotlib pplot every time. Similarly, we import Seaborn as SNS, making it easier to use without repeatedly typing Seaborn. This shorthand keeps our code cleaner and more efficient. But you might be wondering, why do we import Matplotlib as PLT but Seaborn as SNS? It doesn't seem like a natural abbreviation, right? Well, PLT makes sense because it comes from PyPlot, a submodule of Matplotlib. However, SNS for Seaborn is a bit different. The truth is there's no strict rule behind it. It's simply the convention chosen by Seaborn's developer. Some people speculate that SNS might stand for Seaborn Statistical, but there's no official explanation. It was likely chosen because it's short, easy to remember, and avoids conflicts with other common abbreviations. You are free to use AAA instead of SNS if you want. However, most examples and documentation on the web use SNS for Seaborn. Since the majority of developers follow this convention, it's a good idea to get used to these common naming habits to make reading and understanding code easier. Let's start with a simple line plot. Imagine we're tracking the number of times you check your phone per hour. Matplotlib provides basic plotting tools like line charts. We just need to provide x and y values, and Matplotlib takes care of the rest. Let's break this code into 5 parts and go through each one step by step. This is the library import section we discussed earlier. I totally understand memorizing these commands isn't always easy, especially with such long library names. However, in real-world applications, having a few key imports memorized can make your coding process much smoother and more efficient. The more familiar you become with them, the faster you'll be able to work. This part defines the data we want to visualize. We have two lists here. X represents time, like first hour, second hour, etc., and Y represents the number of times a person checks their phone at each hour. As you can see, the numbers increase over time, meaning phone usage is getting more frequent as the day goes on. But we're going to make it easier to understand through visualization. Now let's plot our data using Matplotlib's plot function. This will create a simple line graph that connects our data points. Lex is our x-axis, horizontal axis. I is our y-axis, vertical axis. Macro adds small circles at each data point so we can see them clearly. Line style connects the points with a solid line. Color makes the line blue. With just one line of code, we've created a graph that visually represents our data. A graph is much easier to understand when it has clear labels and a title. Let's add them now. Xlabel adds a label to the x-axis so we know it represents time. Ylabel is the y-axis to indicate it shows the number of phone checks. Title gives our graph a meaningful title. Now, our visualization is much easier to understand. Finally, to actually see our graph, we need to display it using plot. Show. This function tells Matplotlib, okay, we're done setting everything up. Now show the graph on the screen. Once you run this, you'll see a nice, clean line graph representing phone usage over time. Now, I hope you can understand the entire code and apply it effectively to your own situation. Here is the result. We had 5 data points, and since we instructed it to connect them with a straight line when visualized, this is how it is displayed. If you set the line style to 2 minus signs, you can create a dashed line like this. If you leave line style empty, only the data points will be displayed without connecting lines. There are many different line styles available. You can even create small dotted lines using colon, and you can also remove the data points if needed. You can check more styles on the official Matplotlib website. And next thing is bar charts. Bar charts are useful for comparing categories. Here, we define categories and their values, and Matplotlib helps us plot a bar chart easily. Matplotlib is great, but sometimes we want more visually appealing plots. That's where Seaborn comes in. It simplifies plotting and works directly with pandas data frames. Scatter plots show relationships between two numerical variables. Here, Seaborn makes it easy to create a scatter plot using a pandas data frame. The left side shows a pandas data frame, and the right side displays a scatter plot. If you want to draw lines in Seaborn, you need to use linyplot as well. The scatterplot function in Seaborn does not have a linystyle option because it is designed to visualize individual points rather than connecting them with a line. However, the advantage of separating scatter plots and line plots is that it gives you more control over the visualization. In this case, the points are shown in blue and the line is displayed as a red solid line. Please pay attention to the fact that the same data, x and y, were given here. If you set this differently, you can create a graph with an entirely different interpretation. This allows for greater customization, making it easier to create exactly the plot you want. Next step is histogram. Histograms help us understand the distribution of data. Seaborn allows us to quickly create a histogram and even add a smooth curve KDE to visualize the shape of the data. Let's create some data for our histogram. We'll generate 1000 random numbers from a normal distributions, also called a bell curve. What's happening here? Rand function of NumPy generates 1000 random numbers that follow a normal distribution. And visualize the distribution of our data using a histogram, the function hisplot creates a histogram using our dataset. And you can see beans. The parameter called beans may be very new to you. What is beans? Imagine you have a pile of numbers and you want to organize them into groups or buckets to see how they are distributed. The beans parameter controls how many buckets you divide the data into. More beans to smaller, more detailed groups, fewer beans to broader, less detailed groups. For example, if we set beans 30, the data is split into 30 sections, making the histogram more detailed. And KDE might also be very new to you. KDE stands for kernel density estimation. But don't worry about the fancy name. It simply draws a smooth curve over the histogram to show the overall pattern of the data more clearly. Think of it as a flexible curve that helps you see trends without relying on rigid bars. If KDE equal true, Seaborn adds this smooth line, making it easier to see patterns. If KDE equal false, only the histogram bars will be shown. Now you have a good understanding of the entire code. If you have time, try explaining it line by line. This is a great way to check your understanding and reinforce what you've learned. By practicing this, you'll gain confidence and improve your ability to write and explain code effectively. Seaborn allows customization like changing styles and colors. This makes our charts look more professional and easy to understand. Check out the official website to explore other styles as well. Heat maps are useful for showing correlations or numerical data distributions in a grid format. With just one line, Seaborn lets us create a visually appealing heat map. A heat map requires 2D data, so we will generate a random matrix of values. Here, we use NumPy's rand function to create these random values. Imagine this data represents the sales performance of 5 products across 5 different months. We'll use a heat map to visualize it. The parameter anode displays numerical values inside each cell of the heat map. And CMap parameter sets the color map to a blue-red gradient, where cool colors, blue, represent lower values, and warm colors, red, represent higher values. Heat maps are great for identifying patterns in numerical data. The colors represent different values, making it easy to spot trends at a glance. There are various color maps available, so feel free to explore them and choose the one that best fits your visualization. We've learned how to use Matplotlib for basic plots and Seaborn for more advanced and visually appealing charts. The next step is to practice with real-world datasets to gain confidence in data visualization. Now we are in chapter 3. If you're feeling overwhelmed, take a break and come back when you're ready. Static charts are great, but sometimes we need more interactivity. What if we want to zoom in, hover over points, or filter data dynamically? This is where Plotly comes in. It helps us create interactive visualizations that make data exploration more engaging and insightful. Before we start, we need to install Plotly using pip. Once installed, we can import it as Plotly Express or simply PX for short. Plotly Express is a high-level API that makes it easy to create interactive plots with just a few lines of code. Creating an interactive line chart with Plotly is super simple. Just provide your data, define the X and Y axes, and Plotly does the rest. You can hover over points, zoom in, and even export the chart easily. Let's interact with the Plotly graph using the mouse. Drag a specific area to zoom in and get a closer look. Hover over a point to see its exact value in a tooltip. Use pan to move around the graph. Try zooming in and out to explore different details. You can even download the visualization as an image file for your report. If you lose the pinpoint to view the entire dataset, click Autoscale in the upper right corner. Bar charts are useful for comparing values across categories. With Plotly, these bar charts become interactive, allowing users to hover over each bar to see detailed information. You can use scatter plots very easily as well. Even with the same data, if you use the scatter function after px, you can see the scatter plot like this. Histograms are great for understanding data distribution. With Plotly, you can hover over each bin to see exact values, making analysis more detailed. Pie charts are commonly used to show proportions. With Plotly, users can hover over each slice to get precise percentage values. It makes pie charts more intuitive and useful. Heat maps are useful for showing relationships between variables. With Plotly, we can create colorful, interactive heat maps where users can hover over each cell to see values. Plotly allows us to customize our charts extensively. We can change themes, colors, axis labels, and even the position of legends to create a visually appealing presentation. We've explored how Plotly makes data visualization more interactive and engaging. It is widely used in web applications and dashboards. The best way to learn is to practice with real datasets. Try it out and create your own interactive visualizations. Now that we know how to create visualizations, let's apply them to a real-world probability puzzle, the Monty dilemma. This classic game show problem tests whether switching doors increases your chances of winning. Let's quickly go through the code and then visualize the results. We start by defining a function Monty switch truth, which runs one round of the game. You can get full code at here. Click the link. Now, let's run this simulation many times and see the results. One round of the game is interesting, but probability really comes to life when we simulate it thousands of times. Let's do that. We run the game 100 times for both strategies. Switching doors, sticking with the original choice, we count the number of wins for each strategy and calculate the winning probability. Now let's plot the results to make the probabilities easier to understand. We use a bar chart to compare the winning probabilities of the two strategies. Seaborn's bar plot makes it visually clear that switching is the better strategy, winning about 66% of the time, while staying wins only 33% of the time. Now, let's take a closer look at how the winning probabilities behave as we run more and more trials. This line plot shows the probability of winning over an increasing number of games. But first, let's talk about what cumulative probability means. Cumulative probability simply means keeping track of the overall trend as we perform more and more experiments. Instead of looking at individual game results, we calculate the winning probability up to that point. At the beginning, with only a few trials, the probability fluctuates a lot. But as the number of trials increases, the probabilities stabilize around their expected values. In the graph, the blue line represents the switching strategy, and the red line represents the staying strategy. We can see that over time, both lines approach their theoretical probabilities, about 66.7% for switching and 33.3% for staying. The dashed horizontal lines indicate these expected values. This visualization is important because it shows how, in probability experiments, the more trials we conduct, the more accurate our observed probabilities become. In the short term, randomness can create fluctuations, but in the long run, the law of large numbers ensures that our results align with the theoretical probabilities. So, what's the takeaway? Switching doors really does give you a higher chance of winning, and the more trials we run, the clearer this becomes. Now, let's take a closer look at the individual outcomes of each experiment. This scatter plot displays the results of each trial separately. On the x-axis, we have the trial number, which represents each game played. On the y-axis, we see whether the player won 1 or lost 0. Each blue dot represents a trial where the player used the switching strategy, and each red dot represents a trial where the player stayed with their original choice. Since this is a binary outcome, all points are plotted at either 1 or 0. What can we observe? The blue dots S, that means switching strategy, appear more frequently at 1, confirming that switching wins more often. The red dots, that means staying strategy, are mostly lower, indicating that staying results in fewer wins. This visualization helps us understand how each strategy performs on an experiment by experiment basis rather than just looking at overall probabilities. The key takeaway: each individual game is unpredictable, but over time, a clear pattern emerges. Switching wins more frequently than staying. Now, we're going to take our Monty Hall dilemma simulation one step further by using pandas data frame for visualization. So far, we've worked with individual plots, but organizing our simulation results into a structured data frame will allow us to analyze and visualize the data more effectively. Let's write some code to convert our Monty Hall simulation results into a pandas data frame and explore new ways to visualize the data. Take a good look at the last line. We are using data frame. Here, we've effectively visualized all three doors and how often each one is selected by Monty. This helps us better understand the pattern behind his decision making in the Monty Hall dilemma. In this heat map, we're comparing the player's final door choice with the actual location of the car when using the switching strategy. Each row represents the door the player ended up choosing after switching, and each column represents where the car was actually placed. The numbers inside the heat map show how many times each combination occurred during our simulations. If switching is working as expected, we should see a clear pattern where the player's final choice aligns with the car's location more often than not. This visualization helps us confirm the probability advantage of switching. This heat map compares the player's final door choice with the actual car location when using the staying strategy. Each row represents the door the player originally picked, and each column represents where the car was actually placed. The numbers inside the heat map show how often each combination occurred during our simulations. Unlike the switching strategy, here we expect to see a more even spread, since the player never changes their choice. This visualization helps us confirm that when staying, the player only wins about 1/3 of the time. matching the theoretical probability of the Monty Hall dilemma. Last time, we discussed what happens when the Monty Hall dilemma has 5 doors instead of 3. Now, let's visualize it in the same way. By increasing the number of doors, the probabilities shift, making the advantage of switching even more significant. This visualization helps us see how the player's choice and Monty's behavior change when there are more options available. This makes it very clear. And now let's take a look at how the winning probability converges over multiple trials. Just like in the 3-door case, we can see that as the number of trials increases, the probabilities stabilize around their expected values. With 5 doors, the impact of switching becomes even more noticeable as the probability of winning by switching is now much higher than when staying. This visualization reinforces the key idea: the more doors there are, the greater the advantage of switching. One useful visualization is a Sankey diagram. With 5 doors instead of 3, the probability dynamics change, and a Sankey diagram helps us track how choices influence outcomes. This visualization clearly shows the flow from the player's initial choice to the actual prize location, and finally to whether they won or lost. Here's how it works. The first stage represents the initial door the player chooses. The second stage represents the door where the prize is actually hidden. The final stage represents the outcome, whether the player wins or loses. By comparing the diagrams for switching vs staying, we can visually confirm that switching leads to more wins. The connections between stages reveal clear patterns, helping us understand why switching is the better strategy, especially as the number of doors increases. This is about the stake case. And this is a final page. We take a deeper look into why switching is beneficial in the Monty Hall dilemma with 5 doors. We break the game into 3 stages. Was the player's initial choice correct? Did they switch or stay? Did they win or lose? If you follow the flow, you'll notice that most wins come from switching because the chance of picking the right door initially is low. This makes it easy to see, step by step, why switching gives a higher probability of winning instead of just looking at numbers. The takeaway: the more doors there are, the stronger the advantage of switching. Congratulations, you've made it to the end! Probability isn't always intuitive, but visualizing it makes it clear. Thank you for following along, and I hope this changes the way you think about decision making and data analysis. Keep exploring, keep questioning, and most importantly, keep switching. Thank you.